A very good morning to Mr. Suresh. I'm Com. Now our group DKMS level will discuss about our proposal system IoT-based smart cat farm. Here is the poster that we have constructed for explaining our system. In this page, it's showing the total emission of carbon footprint that before the implementation of the system, and here is the after the implementation of the system is reduced and is reduced until 62.67 K, the total emission of the carbon footprint. And here is some the calculation of the carbon footprint reduction on the power consumption. And here is the reduction of the methane gas after the implementation of the system. Here is the demonstration of our integrated system. This is the overall GUI that we have designed. Is contained with the graph, and then the display, LED button, and so forth. I'll pass to Dia for explaining for the following part.
Everyone, this is my part, which is the smart methane gas system monitoring. So as you see, we can test the methane by using the lighter for the gas, and then here is the readings of the methane, and here is if the methane level goes more than 30, it will show that the LED of the supplement feeding, which the tag will be on for the supplement feeding. So as you see, we can test it, and the value of the methane is going more than 30. If more than 30, the LED of the supplement mechanism will be on. So I'll pass to my friend Moad to continue.
Hello everybody. Automated cattle tracking system using RFID system and feeding system. This system will go to scan the tag in the farm and will show the available tag in the system. As you see here, S4 is available by scanning the stock of the livestock, and we will scan one by one to show which one is available and recognized by the IoT system. Now we're going to scan N4, and it appears in the application. These are available. After this, the system will scan one by one and show the result. And whenever there is available livestock in the farm, it will supply for specific. As you show in the motors, it's supply for the available only, and will return to the normal condition. I will thank you. Best, my friend Saleh.
Hello everybody, this is my part, heating and lighting monitoring system by using solar power management, which used to reduce the carbon and to supply the whole project. The lighting system will start working when there is a shadow as shown in this video, and the data will be transferred to the dashboard. As see, the lighting is on. And here is the heating system. When the temperature more than 13, the fan will start working, which represents the AC or condition for the whole cattle or livestock, as shown here. So we reduce the carbon in this threat objective by using the solar power management. And now I will pass to my friend Kong.
Hello, my name is Kong. Now I will explain the part of automated carbon monoxide monitoring and controlling system. Now I'm burning the incense stick for emitting the carbon monoxide. And then I will move it close to the sensor MQ9 for detecting the concentration of the carbon monoxide in ppm value. As well, you can see the LED, the ppm is increased until 1.585, and then the LED is turned into red color. And now the fan is on, which demonstrating the direct air capture system is start to operate for directing the high concentration, high CO concentration gas air direct to the compartments. And here is the dashboard showing the CO concentration. And now I'm using the hair dryer to remove the carbon monoxide to lowering the concentration. And then as well, we can see on the dashboard, the concentration is reduced gradually. And then this will continue until it's below 0.5 ppm, and then the LED will return to green color again. Here is the overall graph that we show in the integrated system. Thank you very much.